Hello.
So we are back.
And today we're gonna learn about diodes. So diodes are an important part from the electronic industry.
All right.
So,
But wait, before we started,
Yeah.
let's not forget our today's sponsors, PCBWay.
oh yes, PCBWay. PCBWay is your one-stop solution based on the fact they have all kind of PCBs. 3D printing, CNC, sheet metal, all are available on their website. You'll find a link on the description with their website. But you know what? Every time you register, every new register on the website, they have $5 credit.
Oh, that's cool.
And $5 is about 10 boards. So basically you get 10 boards for free, and all we have to do is to pay for the postage.
Nice.
So in the future, if we have like complicated projects, we can just order the PCB for whatever we need.
I like those.
We shall do it.
Indeed.
Now let's go back to our diodes.
Let's go.
So diodes are some simple devices. Yeah.
Yeah.
Basically, what they are doing, they are leaving the current to flow in one direction. And that's all.
From plus to minus?
Yeah.
Okay.
No, actually from minus to plus.
Oh,
So basically,
okay.
you add it on a serial mode, yeah? So here
Yeah.
you'll have plus, and the plus is moving forward.
Okay.
Yeah?
Because they have a sign that means this is the plus. Right?
Yeah, exactly. Exactly.
Mm-hmm.
But if you come with a plus, with a power supply, yeah?
Yeah.
So you come with a plus here, like the power supply is, yeah? Plus here, and the plus is, the current is will move forward.
All right.
So the ring is where in what side the current is moving.
All right.
Yeah?
Yeah.
Do you understand?
Yes.
Good. Now, we finished.
What do you mean we finished?
Yeah, that's what the diodes are doing. So everything else is bullshit.
What do you mean?
All the theory behind of the diodes and everything is nothing.
Yeah, but how should I know when I should use a diode?
When you need the current to flow in only one direction.
Oh, lol.
Yeah, that's all. Of course, they come on different size. This is a diode, do you see?
Yes.
This is a diode. Yeah?
Yeah.
Now,
Don't tell me this one is a diode as well.
No, here are 4 diodes.
4?
Yeah.
Oh, okay. I thought there is a diode with 4 legs.
I mean, okay, it's
Okay.
it's a little bit more complicated, and
Okay.
there are few types of diodes.
All right.
But basically, that's what they are doing.
Yeah, we use one of these on our DY
Yeah,
schematic.
yeah.
Yeah.
But anyway, for our area, yeah,
Mm-hmm.
for repairs, all we have to do about the diodes, they drive the current in one direction, and based on the size of the diode, they can carry more or less current.
Okay.
And also the voltage, the voltage when they get burned.
Yeah.
Let's say you have 100 volts diode, yeah?
Mm-hmm.
If I come with, here I have a circuit and I come with 200 volts, so the voltage will go in another direction, so the diode will get shorted.
Okay.
Yeah.
And it will die.
Yeah,
Okay.
it will get shorted. That's how the diodes are dying.
Mm-hmm.
So, yeah, I think we are done with the diodes.
No, it must be something else. It must be something else. It cannot be that simple.
Now, you know what, I'm joking, but that's all
okay.
about the diodes.
Okay.
Yeah?
Yeah.
So what do I want to know? One more time, I will repeat. The current is flowing in one direction.
Yeah.
Yeah?
Yes.
The second, depends of the diode. You have usually a voltage limit.
Okay.
Yeah? So you can use it on that circuit. But usually the voltage are like from 100 volts to 1000 volts. Yeah?
Mm-hmm.
So if you have a circuit with 12 volts, I can use any diode from 100 to 1000, yeah? Then the current. So you see those diodes probably can carry like few hundred milliamps.
Yes.
Yeah?
Yeah.
This one probably like 5 amps or 7 amps, yeah?
Mm-hmm.
And this one, they have 4 diodes, probably like 5 amps, but you don't know yet what is this, yeah?
Yes.
So this is the diodes. There are many kind of diodes.
Mm-hmm.
What is inside? They have a junction, PN junction. You see, you remember the transistor, they have PNP and NPN?
NPN,
Yeah? They have a PN junction inside. Probably know this one. Those are, you know what diodes are these? These are specific diodes. This is the new type. And they are used a lot into the electronics, yeah?
Okay.
So I will show you, I will show you the
Wait a
name.
second. But this diodes has a resistor inside?
Resistance.
Resistor.
Everything has a resistance. Like a virtual resistance.
Okay.
So basically when the
because you said everything has a resistor
Yeah.
inside. Yeah.
when the current is flowing,
Yeah.
you lose some current onto the diode. And basically this is something else I want to speak about you. Checking the diodes, you'll see what voltage you lose. You lose voltage over a diode.
Okay.
Yeah?
Yeah.
You understand?
Yeah, but it's getting hot as well?
Yeah.
Yeah.
Obviously, anything
Yeah.
carrying current, it will get hot.
All right.
Why is getting hot?
It's getting hot because of the voltage that is losing. It's transforming in the heat.
It's not losing voltage.
Losing current.
Why is losing current?
Losing current.
Why is losing current?
Because has a resistor. inside.
Internal resistance.
Yes.
Exactly. Yeah?
Yeah.
Now, I want to read the name of this diode because the people make fun of me when I was saying this diode, yeah?
And do you want people to...
Yeah, I want to make fun of you.
me?
Yeah,
Okay.
exactly.
So one is not enough. It must be two.
Yeah.
Okay.
So, read the name of this diode.
This one that you wrote there
Yeah.
is Schottky diode.
How do you know?
I don't know. It's Schottky diode.
For me, it's
Scotchy.
but the people saying Schottky.
Schottky.
That's how
No,
that's how
because
you.
CH you read it sh, right? And the Y from the end you don't read it like Kai. You know, when you say Kyle.
I don't know though. I don't. For me, it's looking like Schottky.
No, it's Schottky.
Anyway.
So
Okay.
I was right?
Oh, yeah, you're right. Yeah.
1-0. So people will not make fun of me. Okay.
Okay. So the diode symbol is like this. That's all. And this is the ring. You see this one? This is the ring. That means plus and minus. Yeah.
Yeah.
And obviously the current flow, it will be like that, right?
Yes.
Hard?
No.
Now the Schottky diode, the symbol is different. And here has something like that. And that's the Schottky diode in the same way, plus and minus.
Okay, but what is different?
What is the difference? The difference, the Schottky diode is kind of same like the MOSFETs. MOSFETs compared with the
Transistors.
So Schottky diode, the voltage you lose across the diode, it's around 0.2, 0.3 volts. 0.2, 0.3 volts.
Okay, what about the other one?
0.3 volts. Okay? The other one, on this one, you're losing around 0.6 volts. 0.6 volts.
Okay, so you're losing more current
On a normal diode.
on the normal one.
Yeah.
So that means the normal one will get hot easily than this one.
Compared with the Schottky diode,
Yeah.
Another big difference is the switching speed.
The speed that the current will
No,
go?
you remember what I told you about AC?
Yeah.
So I said the AC is changing it's changing plus or minus.
Yeah.
Minus plus, yeah? Basically you have the wave. So this one from a normal diode is not that fast.
Okay.
I mean, can manage some speed. But this one, the Schottky one, is very fast. It's a very fast diode. That's why on the switching power supply, they are using only Schottky diodes. So it's clear?
Yeah.
You sure?
Yeah.
Okay. So we have the multimeter here. Yeah. Let's check the diodes.
All right. So I said the mark is the plus, and this is the minus.
Okay. And we have nothing.
We have nothing.
Yeah.
Yeah.
And on the other way, turn it around.
We have 0.1
157. You can see. So
157,
basically, volts.
volts. Yes.
Yes, it was like 157 millivolts or 0.15 volts. Yeah? Good. Now check one of these. 1N4148, it's a classic diode.
Let me take one out. All right, so I should check like this.
So how much it is?
It's 0.606
What?
volts.
Horses? Volts.
Volts.
Volts, okay.
Yes.
And on the other way?
In the other way, it's 0.
Nothing, yeah?
Nothing,
So you
yeah.
see, it's driving the current on one direction.
Yeah.
Okay?
Yeah. Easy.
Now I checked online these diodes, so actually I underestimate those diodes. So those diodes, the diodes what we have here is like 15 amps diode, 45 volts, 15 amps. So it's
Okay.
quite strong one. Okay, so all clear about the diodes?
Yeah.
Yeah? Okay, so the another type of diode is called Zener diode.
I heard that word.
Huh?
I heard that word on
Yeah?
the videos. Yes.
The sign of the diode is like that. And on the same way you have plus and minus. Now, what is a Zener diode?
What is that?
A Zener diode is a diode which it will allow the other direction the current to flow on a certain voltage.
Okay.
So let's say you will find diodes like 3, 5 volts, 10 volts, you know.
Okay.
When you have the inverse voltage reaching the, for the diode specification, it will let the current pass. So on one side, it's working as a normal diode. On the other side, it's working, so it's working like a normal diode, and on the other side has a, how it's called, has a step when it starts driving the current on the other direction. Do you understand?
Yeah, but what it's used for?
What it's used for? Very simple, yeah? And I'm glad you asked. You have a power supply, plus power lines, minus, yeah?
Yeah.
They use the diode like this. So what will happen? You have 5 volts Zener diode. Usually it's 5V6. When the voltage is going over 5 volts, the diode, it will pass the current. That means the diode, it will short the voltage to ground. You understand?
Oh.
Yeah. So they are using those kind of diodes to protect things like data lines. On the phones, you'll see they have those kind of diodes on the data lines. Or a lot of diodes are used to regulate a power rail. Okay?
Yeah.
Complicated?
A bit.
When you see a Zener diode, you know that diode has a value which the diode, it will get shorted.
Oh, okay.
And mainly they
So
are using
it
this
works
for
like a protection.
a protection, exactly. Even on the laptops, on the 19 volts, they are using like 24 volts Zener diode or something like that.
Okay.
So if the voltage goes over, the diode, it will send the current to ground and it will get shorted, obviously, if the current is too high, and probably it will be high. And the diode will get shorted, it will short that power rail, but it will save the device.
Oh, easy.
Oh,
that's good.
Yeah?
Yeah.
So are good. The Zener diodes are good, right?
Yeah.
But anyway, this is just one use for the Zener diode. Another use is they are offering like a reference voltage. So let's assume we have two power rails, yeah? We have plus and we have minus, yeah?
Mm-hmm.
Good. So what we'll have here, we're gonna have a resistor, yeah?
Mm-hmm.
And then we're gonna have a diode, a Zener diode. Yeah?
Yeah.
What will happen here? That's my question. So this is a resistor. What I will have here, what voltage I will have here. So because I have a resistor, the power rails, it will not get shorted, right?
Yeah.
So let's say we have here, we have 12 volts. 12 volts. Yeah?
Mm-hmm.
That's plus, here is minus. And the diode is 5 volts diode. What will be the voltage here? Just think.
Wait.
So you use a resistor
Yeah, but
to limit what?
To limit the current.
The current. So I'm limiting the current. That means my diode, it will not get shorted.
Yeah.
But it will pass anything which is over 5 volts. Yeah?
Yeah.
So that means the voltage from here, it will be
I'm not sure what voltage you have there because of that resistance.
It doesn't matter. Because the diode, it will not allow any voltage to be higher than 5 volts. It will send it to ground. So doesn't matter the resistance. If the resistance is too low, that means the current will be higher, yeah?
Yeah.
In this case, the diode will just get shorted and you'll have 0 volts and that's all, yeah?
Yeah.
But usually they are not using to short the diodes, no point shorting the diodes. So you are using a higher resistance to lower the current, so the diode it will not get shorted.
Okay.
Yeah, because even the Zener diode, they have a limit current.
Yeah, so
Milliamps, amps,
so
yeah?
you should have like 5 volts there.
Exactly. Or we have 12 volts diode, not 12 volts, because you have input 12 volts, like 10 volts diode, we're gonna have 10 volts here.
Yeah.
And you can get that voltage as reference. So it doesn't matter if here I have 12 or I have 15.
Mm-hmm.
Here will always be 5.
Okay.
You understand?
Yeah.
Complicated?
No.
It's not hard.
It's not.
We're gonna work with Zener diodes, yeah?
Okay.
But don't worry. This is just, explain you like in the big picture with diodes.
Mm-hmm.
Yeah? Good. Now going back to our thingy. I just want to go quick, yeah? Just want to go quick over the Transformers.
Transformers.
Yeah.
The movie? Transformers. There's
these ones.
Can this one can transform me in a princess?
Why they are using Transformers? Why do you think those devices are even built?
I don't know, but this one is a big one.
Yeah, kind of, yeah.
I mean, obviously they transform something.
They move from Transformers
Mm-hmm.
to switching power supplies, yeah?
Okay.
Because those are heavy, expensive,
Yeah.
and you need some electronic to regulate the power delivered by the transformer.
Mm-hmm.
You understand?
Yeah.
Okay. Now, the transformer working with AC voltage, yeah?
Okay.
The transformer, it will not work with DC. So like our transformer from here. Now the transformer, like what we have here. So how you have to keep in mind the transformer are working only with AC.
Okay.
Yeah?
Yeah.
Only with AC. In our case, 220 volts. And the output, what we have here are 3 wires. That means we have 2 separate coils. Okay? And the material they are using between the coils. So you have to keep in mind that the output is completely separated from the live part. So you cannot get electrocuted with using a transformer. That's the reason why we are using the transformer. So the electronics behind the transformer is safe.
What if the transformer is faulty, or it can get faulty?
No, I never found a transformer like, okay, to pass the live part from here.
You said if you touch those 3 wires,
Yeah.
nothing is gonna. I mean, you don't get electrocuted.
Yeah.
I'm not gonna touch them.
I told you you'll start feeling the current from like 50, 60 volts up.
Oh, okay.
Yeah.
Yeah, but that's 220. What if this one is faulty, or what? No.
What do you mean faulty?
I don't know.
Has wires. Yeah.
Okay.
You see here. This is wire. These are coils. Yeah, wires.
All right. So they never get faulty.
They are getting faulty, but usually they are getting shorted or interrupted. And usually it's happening. I mean, not so usually, always it will happen here.
That current never gets to those 3 wires.
Yeah, because that's how the transformers works. It's transferring.
Okay.
You see, you have here a coil. It will create a magnetic field, and you transfer the power on the output.
Okay.
So the power of the transformer depends on the size of the... this one probably, not sure if this one is metal. It's a special metal, which is not magnetic, but is retaining the magnetic field. So based on the size of the transformer and the size of the wire, you actually, you get some power on the output. More power or less, depends on the size of the transformer.
Okay.
Yeah? Now, the transformer are still used even on those days, but not for this kind of work. Okay, you see, this is a TV board, yeah, and I want you to see the transformer.
Wait, there is a transformer?
Yes.
Oh, okay. I thought those ones are transformers.
No, they have to use transformers on electronics like this. You have to separate the live part from the device. You understand? Because otherwise you'll get electrocuted. So you have to do it. So you see, this is a transformer, but the coils are around some ceramic, like ferromagnetic ceramic. Yeah.
Yeah, but this one has 4 wires.
Yeah, you can have how many outputs you want.
Oh, okay.
Okay, this is a switching power supply. We didn't learn yet, so let's focus on this one.
Okay.
Now, I will plug the transformer and I want you to check the voltage. This is a dodgy connection, I know. Just be careful, don't touch it. So I plug the transformer, touch the wires.
No way.
Touch the wires.
No way I'm gonna touch it.
You can do...
You first.
No, look.
No.
You see?
Okay.
You see, so the transformer... Wait. I'm touching them. You can see. Look, I'm touching them.
Okay.
Yeah. Or,
oh, okay.
Yeah.
Yeah.
Nothing happened.
Good.
You know when the people are scared? When the knowledge is missing. Doesn't matter if it's about electronic or something else.
Obviously.
So I just explained you how the transformer are working.
Okay.
But you are still scared.
Of course.
So check the voltage. The multimeter is on AC.
All right. So the voltage.
So we have 2 coils here connected together. Yeah.
All right.
So obviously, look on the screen. Yeah. So here you have 1 voltage. Here you have another voltage. Yeah. And here you have another voltage, so you can check basically from here to here, or you can check from here to here.
Or from there to there.
Or from here to here.
Yeah.
Okay? Now let's check with the multimeter.
All right. Let's start.
You can put the fingers. It's
No,
fine.
I don't want to put the fingers. It's okay.
I just told you how the transformer are working.
Trusting.
Yeah.
Okay.
I'm joking. No, you can touch them. Don't touch those.
I don't know. I don't. Wait. I do have a life insurance, so
Yeah.
it's safe.
So test them. So from there to there, you have what?
38 volts.
38 volts. Okay.
Oh wait. Wait. Oh, okay. Yeah, 38 volts.
Okay.
So from here to here,
You have
25.
25. Okay.
And from here to here,
You have
13. 13.
13 volts.
All right. So you have difference.
Yeah.
Difference. So you have 38, 25, and 13.
Yeah, but from where to where?
What do you mean from where to where? From here to here, you have 38.
Yeah, but I'm not happy with that. I want to know the highest voltage, which is this one. Yeah, so probably this one is the highest, right?
Yes.
And I want to know
Which one is the lowest now?
which one is the middle.
Which one is the middle?
Yeah.
Um.
I mean, you can't really figure it out. But probably you can. Yeah, you can figure it out.
I can.
Yeah. So first find the highest. And we know the other
This
one
one.
is the middle.
This one is the highest.
38. So
38.
that one is the middle, yeah?
This one is the middle.
Now use the middle, keep that on the middle, yeah? And check one more time. So we have 25 and
13.
13 volts.
Yeah.
So you
so
see?
This one is the middle.
Yeah.
Yeah.
So it's clear?
Mm-hmm.
Now here it's AC.
Yeah.
Let me show you how the AC is looking. Now the oscilloscope, it's a nice device, you can see signals, yeah? So
to see signals.
yeah.
To see on the monitor.
Yeah. So which one was 13?
This one. The yellow.
The yellow with which one?
I think with this one.
With the red. It doesn't really matter. So that's AC. That's how the AC is looking.
Okay. Yeah, you see it's 13. You say
Yeah,
there.
yeah,
13,
you're saying
yeah,
yes.
13
yes.
volts.
So you understand?
Yeah.
How the AC is looking?
Yeah.
Okay. So in the middle you have 0. You understand 0 volts?
In the middle, does mean here?
Yes,
Here?
yes. You have 0 volts there.
Okay.
Now let's go back to our screen. So we know the transformer outputting AC, right?
Yeah.
Okay. So AC meaning is like that. Okay, so in the middle we have 0 volts. So this is 0 volts. So the voltage it will rise up, like how much you said we have?
13.
13 volts, yeah?
13 volts.
So it will rise up and this it will be positive, right? And this it will be negative. You understand?
Yeah.
Now, how many waves you have in 1 second? These full waves.
13?
So this is the time.
13?
No. Plus and minus meaning you have 2 wires, yeah, from the transformer, yeah.
Okay.
The plus or minus it will change, yeah. How many times? We spoke about this.
We spoke about.
This is time. How many times the plus or minus it will change on my wires per second? Because we are calculating per second.
13? 13 times?
No.
No.
13 is the potential.
Okay.
You see, this is the potential. Yeah, that's what it is. It's the potential. Yeah, from here to here you have 13 volts, right? 13 volts. So how many times it will change plus or minus? How many waves, full waves, I will have in 1 second? We spoke about this
I know.
on the beginning with the AC.
Yeah, I know. But
50 times per second, because the frequency of changing is 50 hertz.
okay.
Yeah?
I completely forgot about that. Because you said it once. You need to say it like more often, you know. That's for information.
I thought you'll keep in mind, you'll remember. Okay?
Yeah.
50 hertz. Yeah?
Yes.
Good. So how we can use, yeah, this kind of voltage? It's AC voltage, because we have to change it on DC, right?
Yeah.
So I'm thinking, yeah, like how we can use it. When it's going to plus, if we are adding yeah, so we have our transformer output. We have 3 wires, right? I'm thinking like that, yeah. One wire is a common wire, and one wire we are using a diode. So every time when it's going up to plus, my voltage will pass, right?
Yeah.
So we are catching this wave, this part of wave, not this one, because the voltage, it will go to 0 and it will get changed. Yes, I'll have a minus here and plus here,
Yeah.
and it will not pass the diode.
Yeah.
Yeah, right?
Yeah.
Let's do it.
What do you mean let's do it?
Let's do it. Let's add a diode. So adding a diode, right? So now we can check on DC. So we can change the voltmeter on DC. So you have like what, like 5 volts?
5 volts. Yes.
5.7 volts? Why? Because on AC you have like 13.
Because of the diode.
Because of the diode, why? On the diode you lose like 0.15 volts, you remember? Why you have only 5.6 volts? Okay, let's go back. Let's go back to our screen. So what you are catching with the diode? So when your diode, it will carry power. Every time, because this we seen on the oscilloscope, so it's looking like that, right? So your diode, it will drive the power always when it's plus here, right?
Yeah.
Yeah? So you are missing this. You are missing this voltage. You are missing the inverse voltage.
Okay.
You understand? So the voltage is rising up to 13 volts. Then it's going to 0, yeah?
Yeah.
Then it will goes here. And here it will be minus 13 volts. Right? Compared with the 0, yeah?
Yeah.
No, this one, it will not pass the diode because it's inverse.
Okay.
Yeah?
Yeah.
So you are losing this sine wave.
Okay.
You understand?
Yeah.
So your diode, it will work here, here,
And
here.
there. But it will not work on the minus.
Exactly. So you are losing basically half of the voltage, right?
Yeah.
So after the diode, how your DC current it looks like? So it looks like that, yeah? Like here, and here it will be a break, yeah? Because you cannot catch this negative voltage, right?
Yeah.
And after that again, and again, and again, right?
Yeah.
So you are catching this, yeah, the positive side of the AC, but not the negative. And on the negative, you'll have a break.
Okay.
Yeah?
Yeah.
So that means you will have on the output, you will have like half voltage, yeah?
Yeah.
Because you see, the multimeter or whatever, it will not get. How can I explain you? You see, from here to here, so here is 0, right? 0. And here what it will be? 13 volts,
13,
right?
yes.
13 volts. After the diode, right? But this is very short. I mean, this it will be equal, like...
No, wait. Before the diode, it's 13 volts.
Yeah. And after the diode is 5, you're right?
Yes, it'll be half.
Yeah. No, really.
It was 5 something.
No, listen. It is 13. But the multimeter, or whatever you want to connect on the output of that diode, it will not get this spike, because this is very short. And it will get this. Yeah? Which, from here to here, you'll have like 5 volts.
Yeah.
You understand? So this is a short spike. Check here you can see?
Mm-hmm.
This is a short spike here. The short spike is 13. But actually your usable voltage is around here. It's like a medium. It's taking like a half value, like, you know, like average, yeah?
Mm-hmm.
It will take the average. And your average, it's what we check, like 5 point something. You understand?
Okay, yeah.
You sure?
Yeah.
Now, the question is how we are catching this, because if we are catching even this one, yeah, from here, we can raise that average. You understand what I mean? We can raise that average.
How?
How we can catch this? That's what I'm asking. How we can catch the negative?
I don't know.
Very simple. And now we're going to learn about rectifier bridge, yeah? So again, you have the AC. You have the AC coils, right?
Mm-hmm.
I will just draw one because we are using only one, the 13 volts one, yeah?
Yeah.
Good. And we are coming, yeah, to one diode, okay?
Yeah.
So this it will be one diode, the one what we have already, yeah?
Mm-hmm.
Plus, and here we have the plus, right? Like, yeah?
Yes.
The one from the earlier.
Mm-hmm.
Then what I know the voltage, it will change. 1 second. The voltage, it will change. And if the voltage, it will change, the polarity, yeah? I will come with a different diode on the other direction. You understand?
Okay.
And this diode, it will catch the negative one. So here, just pay attention, yeah?
Mm-hmm.
Pay attention here. So when it's inverse voltage, I will have this diode, yeah? I will have here this diode going with the plus here. So when it's the other way, I will have the plus here, right? It will not be the ground, I will have the plus here.
Yeah.
Okay. And when it's the minus, I will have like this. And now what I will have here, this is a bridge, this is a jumper, yeah? You jump over a track, yeah? Okay? That's the symbol of jumping over something, yeah?
Okay.
And now I'll have plus and minus.
Oh, that's complicated.
1 second, 1 second.
Wait, but you put there like 1, 2, 3, 4 diodes?
Huh? Yeah, 4 diodes. Give me 1 second.
Yeah.
So when this is plus, this is minus,
Yeah.
okay?
Mm-hmm.
So you will have, when here is plus and here is minus,
Mm-hmm.
you will have this flow. The voltage, it will goes to this diode,
Mm-hmm.
okay? And it will come back. Yeah? It will come back using this diode
Mm-hmm.
back to the transformer, and I will have a circuit, yeah? A closed circuit.
Okay.
Okay, on the other way, when here I will have minus and here I will have plus, right? So the plus, it will go through this diode and I will have plus, yeah? And the minus, it will go through this diode.
And you have minus.
Exactly. You understand? And it's going through my load and it's coming back here, and this one is going through the transformer, and I will have a full circuit.
Okay.
Cool? And
Cool,
that's how we are getting the both. We are getting the minus 13, yeah?
Yeah.
And we are getting the plus 13.
Oh, but that sounds so complicated.
Are 4 diodes, how can be complicated?
Yeah, because there are 4. So many pieces.
Okay, you know what? Just keep in mind this, yeah? Actually, 4 diodes are making a rectifier bridge or bridge
All right, so whatever you...
rectifier. Bridge rectifier bridge probably is the same thing.
All right, so whenever you want to make a rectifier bridge, you have to use 4 diodes.
You have to use 4 diodes, or you can use a rectifier bridge, yeah?
Oh, that one.
Yeah. So you have AC and you have output plus and minus. So simple, right?
I mean, that looks so simple instead of putting 4 diodes.
No, look, you have diodes. You can check the diodes between each pin. You understand?
Yeah.
Usually those get faulty as shorted. Yeah, that's how they are getting faulty. But I just want to have in mind, I mean, not sure how much you'll have contact with this kind of linear power supplies, because the humanity, they move to switching power supplies, yeah?
Okay.
But just to have in mind.
All right. Yeah.
Okay, let's let's connect the rectifier bridge and see the output voltage. No, you don't touch it. Just put the fingers. Just use the fingers.
Yes, I did.
Yeah, like that. So we have
5.3.
5.3. And with the rectifier bridge, let's see. So we have AC. Now you have to check on DC.
Yeah.
So I'll hold this here and this wire here and check with plus and minus. What is the voltage?
11.5.
0.5. So basically we double the voltage.
Yeah.
And the current, obviously.
And the current.
Yeah? You understand?
Yeah.
So that's how you catch the both phases from the AC. Complicated?
No.
No. Tomorrow we're gonna learn about filtering, how you can filter the DC. So now you have DC, but what kind of DC you have? What kind of DC? You have this DC.
Yeah.
Yeah? But this is not a line. So the DC you have after a rectifier bridge, it will be like that. Right? So you catch you catch the both, yeah? But this it will be the DC. So the AC from the input, it will be like that. With the middle line, the 0 volts. Okay, 0 volts. So that's what you will have after the rectifier bridge. That's how it looks. Yeah.
Okay.
So you have to straight up this current. You don't want something like that. Yeah.
Okay.
You want a line. So what you see here, it's a DC current modulated, yeah, with a 50 hertz signal, because you'll have these bumps. You'll have 50 bumps per second. Yeah, that's a 50 hertz modulation. That's how you call it. I mean, it's a DC signal with some AC component over it. You understand?
Yeah.
If you connect this to a speaker, you will see like a buzz, like a 50 hertz. Bzzz, yeah?
Yeah.
That will be the sound. You don't want these kind of things. You are working with DC, you don't want nothing over the DC, like AC. Yeah? So we have to straight up this line.
Okay.
But we're going to learn tomorrow how you can do that. Yeah?
All right.
Yeah?
Yeah.
Good. Complicated?
Things are getting complicated.
What do you mean it's a diode? It's just driving the current in one direction. How can it be complicated?
Yeah, it's a diode. Then it's 4 diodes. Then it's another thing. And
It's 4
another...
diodes because you have to catch the both phases of the
Yes.
AC.
Yeah.
That's why you need 4 diodes. Okay?
Yeah.
Okay. So we're gonna stop now.
I will say thank you for watching.
Like and subscribe if you like the video.
And see you in the next one.
Bye.
Bye.